In this video, we are going to discuss about elementary signals. So the first signal we are going to discuss about is unit step signal. We are going to discuss about only continuous time signal. Here the u of t is equal to 1 for t greater than or equal to 0. For the rest of the values, it must be 0. So I can write it as 0 otherwise. So we can see a person who is applying a brake for certain times. Okay, so the starting point is the starting time. I can write it as t is equal to 0, and uh, since he is applying a brake for a certain amount of time, I can write that one the amplitude. It will look like this. So here the amplitude I have given it as 1, right? So if a person applies a brake, so for continuous type, right, from 0 to 0 is the starting point, and he apply for certain seconds, okay. So and it is 0 otherwise. So this is your unit step signal. So the analogy is applying the brake. So the second one is unit ramp signal. So here also it is we are going to discuss only the continuous time signal. So r of t is equal to t for t greater than or equal to 0. So okay, and 0 otherwise. So this is more like a linear signal starting from 0th time, right? So so here the signal will look like this. So for what is t is when t is 1, r of t is 1. When t is 2, r of t is also 2. So you get a linear type of signal. So this is your t, right? So it will goes on, and it is 0 otherwise. That is for negative value of t, it is 0. Okay. So if I differentiate the r of t with respect to dt, I will get u of t, right? So in other words, I can tell r of t is equal to integral of u of t dt, right? So the next third one is unit parabolic function or signal. So this I can represent it as p of t, that is equal to t square by 2 for t greater than or equal to 0, and it is 0 otherwise. So the signal will look like some t to p of t. If I plot this one, so the signal will look like this. So for 0, p of t is 0. For time t is equal to 0, p of t is 0. When t is equal to 1, it is nothing, p of t is 0.5. When p is equal to 2, p of t is 2. So the signal will look like this, right? It is nothing but a parabolic signal, and it goes on up to t. So when I differentiate p of t, I will get r of t. So only with the help of this signal we can solve the rest of the problems. So that is why we are discussing this one. And another one more important thing is unit impulse function or unit impulse signal. So it is represented by del of t. So the del of t, so I can represent it as for see I have to look into the so the del of t is equal to 0 for t not equal to 0, okay, and integral of del of t dt is equal to 1. for t is equal to 0, right? So how the signal look like means, so the if I plot the del of t, so it is not x of t, it is del of t, or so 1 by del is my amplitude and del is my distance. So the x-axis is t. Okay, so if I multiply this one, I will get the area is equal to 1, right? So this is how you have to represent the sequence. So suppose if you think integral of del of t minus a dt, and you have to substitute, that should be equal to 0. So t value is equal to a. Since I want to make del of 0, so the t value must be equal to 0. So a. So how to represent this one? So at whenever the t is equal to a, okay, you will get the amplitude as del of t minus a. Okay. So for the signal it is 0 for other values of t. So the next signal is triangular pulse function. So I can represent using this signal. So that is equal to 1 minus magnitude of t divided by a for t. So magnitude of t which is less than or equal to a, and 0 for t greater than a. So the signal can be represented like this. So the magnitude is 1, and it ranges from minus a to e. And there is the next signal is signal function. So this is how the signal is. So here the amplitude of the signal is 1 and minus 1. Okay, so it is in short form it is represented like this. Okay, so it is 1 from t greater than 0, and minus 1 for t less than 0. This is about the signal function. Next one is sync function. So the sync function, sync of t is equal to sine t divided by t, right? For t is ranging from minus infinity to infinity. So this is how the signal look like. Okay, here also at 0 the magnitude is 1 here. Okay. So this is a very important way while we are solving the Fourier transform. So the next one is rectangular pulse function. So pi of t is equal to so since it is a rectangle signal, it is 0 otherwise, and it is 1 from magnitude of t is less than or equal to 1 by 2. So the amplitude is 1, and it is ranging from minus 1 by 2 to plus 1 by 2. Okay. So the next one is sinusoidal signal. So the x of t is equal to b sine pi omega t plus theta. So the theta represent the pulse phase shift, and this omega, right? So this omega is nothing but 2 pi divided by t. That is 2 pi f. Okay, so since it is a sine signal, so it will look like this. So from this I can identify the period, and the magnitude is from minus b to b. So in the left hand side it will look like this. Okay, so it goes on up to so this is how the signal looks like. So the next one is real exponential signal. So you can write x of t is equal to e power at into b. So if I consider b is equal to 1, and the a values both are real, and a is positive. Okay, that is a is greater than 0. So we will get the signal like this. Okay, so it is exponentially increasing signal when a is greater than 0. Okay, in similar way, if a is less than 0, okay, you will get the signal like this. So if you see if a is equal to 0, if a is equal to 0, you will get b as your amplitude. So at t is equal to 0, you will get the amplitude as b. Right here, the b value is 1, so it is 1. Okay, so if a is less than or 1, you will get the exponential decaying signal. Okay, so it is not 0. The next one is complex exponential signal. So here I can write x of t is equal to e power st. Okay, so where yes, you know that so this is useful in Laplace transform, theta plus j omega. So tau plus j omega. So e power tau t plus e power into e power j omega t. I can write it like this, right? So e power j omega t, I can write it as cos omega t plus j sin omega t. So whenever the omega is equal to 0, it becomes a real time exponential signal. So what happens when if this tau is equal to 0? So if the tau is equal to 0, it is nothing but a cos of omega t plus j sin omega t. So it is nothing but a so sine combination of cos and sine wave. So it will look like this, right? So what happens when s itself 0? So s itself 0, it will be 1 for all the values of t, right? So the amplitude is 1. And next, if since s is equal to this value,
If no omega is equal to 0, I have already told you. If it is this tau is less than 1, or if it is greater than 1, you will get the real exponential signal value, right? So this we have already discussed, right? So when this is for when it is greater than -1, and this is exponentially decaying signal, right? Which we have already discussed. So totally we have discussed 4 values so far. So this is a fifth one. So if s is equal to this value, and what happens when this tau is greater than 0? So you will get this is called as overdamped signal rate. So it is continuously increasing. Okay. And similar way, if it is less than 0, so you will get the signal, it is continuously decreasing. Okay. In addition to this one, you have a Gaussian function like that.